Okay, so this is my first stream, so I don't know how to do it. So I have this scissor lift, which I basically want to run using this stepper motor, and I printed this part, which basically connects over here, but it's just a bit too loose. So right now we'll jump into Fusion to quickly change the setting of this part. It is too loose over here, and on this part it is too tight, so we'll increase the tolerances over here and reduce them over here. And while it prints, we will connect the Arduino board with the stepper driver. This is the one which usually is sold by Seed Studio. So let's jump right in. Let me switch the scene to Fusion, and over here we can see the sketch. And it seems like 16 is a bit too much. I mean, the dimensions are 16, but let's make it 15.8, so the entire thing should come out. I mean, there is just a bit of a gap, so I think with 0.2, I mean, this is more like eyeballing it, but this thing should be quite good. And now the dimensions have been changed. Let's work our way over here, which is the second sketch. So apparently this is too small. So what I'll do is I will first make an offset over here of 0.2. So that should give us some room. And then, since this is too tight, I will reduce it by 0.8 as well, so it becomes slightly longer. 0.8. I think that is a bit too big, but I think it should work. And now we have to extend these lines. And then we can use the trim command to somehow get another surface. And I'm not a CAD designer, I'm an electrical engineer, but I can make things in Fusion. Maybe not the most efficient way, but. And now we will simply trim it. Finish sketch, and now we have to see the sketch, and then we can actually get rid of this extrusion, and now we can re-extrude this thing. That's not a very good angle, but let's press E, extrude, take this surface, take this. And one thing I realized that it is good to actually go it through, so I can use this gap, because in this thing there is no gap, and hence it is hard to take this support out. So if I have a gap, I can just put like a thing inside, like a file, and then the gap would be more open. So I think that is what I am thinking of. Now let's move back to Fusion. So let's make it an extend type to object, and then this is the object. And with this, I think we should have better tolerances. We can also add a bit of fillet. I think the nozzle can mirror that. So with this, I think we should have a good connection. We can also have a fillet over here. We just love fillets, but they're mostly not required in this case. So let's save it. Copy, export, save it. Copy, let's go to export it. So now let's let's try to import it in Bamboo Studio. One second. If you hear some background noise, it's I apologize for that. Basically, they are digging a tunnel to make a new highway, or the highways are there, so they are trying to make the highway go down. So the quality of life we have over here in this part of Spain improves, but the cost of that quality of life is that we have to bear this noise for a few years, I guess. Well, now we can just print the plate, and it should take 40 minutes to do it. Let me see if yeah, there is a, you can see the green part, so there is support over there. And now we can send it, and then Bamboo Labs will keep printing it in another part of my workshop. And in the meantime, let's start programming the Arduino. So let's move to the desk. So this is the Arduino. It's a USB-C Arduino. Let's see. Well, I have never used this driver, but I think it's the same. It has a ULN, so it's a Darlington bridge, and then we can select over here we want to have VCC, or we want to have a separate motor power supply. I think VCC would be good enough, because I've seen these things run very easily. This is some work strip. So let's have pin 4, 5, 6, and 7 and ground. So we have the ground. Some jump, okay, is not burst strip. This is the burst strip. So I really like this kind of a board because they have so many ground pins and so many VCC that it's very easy to plug things in. And now we go from yellow yellow, orange, red, and brown. So we have these connections and we are missing one for the VCC. So we attach the VCC, and then in terms of connections, we are done. This pin is slightly bent. Okay, so we have IN1 to IN4 going from pin 4 to 7, and that's it. So now let's go to programming this thing. Let's use platform IO. Wait a second. Seems to be plugged in. Let me turn off the Spanish sun. It's better. So we have now let's open VS Code. Um, so I'm just it's just platform IO is just trying to load up. I think with OBS and everything, it's getting a bit slow. Um, yeah, now I can go over here. So let's actually I also wanted to try for these simple things. Maybe I can use some AI to generate the code. Stepper text. Because it's just pin toggling. You just have to do binary toggles. Arduino. Now I think this is the new bootloader because it works well. So let's see how it goes. Into SRC. So here we have to type the code. Let's say so in one was 4. We can quickly make 4 copies of this. 2, 3, 4, 5. 7. And I guess now I can try this thing. It's called row climb. And let me save this so it's written to the disk. I am using ULM283 Darlington to drive a stepper motor. Then show the pins are on the main file. Write new code that moves X steps forward and backward, controlled using serial, such that if I send F200, it moves 200 steps, and if I send B200, it moves 200 steps backward. The step speed should be constant. So let's see how this works. I was in the ask mode. Let's approve its request to write. I think Gemini does not work very well sometimes, but it seems to the Google that the Google's new updates on the model has been working. So let's see the code. So it's 10 milliseconds, 2 steps per revolution. I don't know. I think this motor does not have 200 steps per revolution. And correct. Save serial. Yeah. So I have to send a new line. Starts with F. And then move stepper. So it basically takes the sequence for forward and backward, and it's doing the typical things to move the stepper of switching the wires. Let's see if it works. Okay, so we have to declare these prototypes of these functions. Move stepper. Stepper. Usually we have to give some int and int. Let's see if it works. So let's flash it and see how it goes. Let's move to the disk view. So this has been moved to VCC. Let's see if it responds to any commands. It doesn't seem to be replying to any of my commands. Yeah, it works. You can see it's moving 200 steps. I think it's easier if I put a tape on this thing. So let me send again the command of command. So you can see it's moving. So well, I think this was way faster than I had imagined, and I think it's working quite well. And then if we do B200, it works in the opposite direction. So while you watch this move 2000 steps, let me just quickly grab the 3D print from another part of the workshop. So this is the new part which came in. Let's see if we have to rework the dimensions or not. So this thing sort of fits. It's a tight fit, which is what I was expecting to have a little backlash. And now, see, let's remove the, let's turn on the light. Let's remove the infill. So this is the thing. Yeah, I think this time we have a nice fit. It's still a bit tight, but I think it's a bit tight, which is okay. because we don't want it to roll around, but I think with a bit of sanding I can make it fit even better. So let me quickly fit this thing in. We can use a nose plier to push this in. I don't have a lot of tools over here, but I have enough tools to make these small things. It seems to be quite centralized, quite balanced. And now let's attach our motor to it, and let's see if it works. Well, I hope that the motor does not rotate, so I will hold it in place. And let's send a command. So you can see it, I will do it like this. Let me hold the motor. Let's send a command for 200 steps. Ah, yes, it's rotating. I think the speed is a bit too low. So what I will do is I will move to the scene, and then let's make the step delay to 5 so it's faster, and that's it. Let's reflash it, and now let's go back to the terminal and send F2000, and so you can see I will move to the desk view. It's just moving in the opposite direction. So I need to do B to move it upside. B. So you can see that the gap is increasing. Let's send a larger value. I think if I send something more than 200, it's not working. So let me see why is that. No, we're not using steps for resolution. So, So I just made sure that it is telling me how many steps it's moving, because on the terminal of I cannot see anything on this terminal, so it knows I'm moving 200 steps. So I'm basically closing the thing now. Let's move 400. So now I'm moving 400 steps to open the rail. Let's move to the desk cam so you can see B. So now I'm moving 1000 steps. I mean, the torque of the motor is good enough to move this up. It's just too slow, so maybe I can increase the step delay. Sorry, decrease the step delay. Yeah, I think that is what I will do. So let me decrease the step delay to just to 1 and see if it goes any. I mean, obviously it will go faster, but it's uploaded now. And let's send B to B2000. So it seems to be moving very well. Let's try to keep it like this. So that is how we want it to be. Let me see if you are seeing anything. Yes, you are. Let me make sure everything's in proper view. Now let's put something like a cup. Yeah, I think a cup is a good example. And see if this thing gets lifted up, so we can conclude the video. Well, it did move up. Now it will be moving down. So I think we have a successful experiment, and I mean, I'm doing it for fun and also to understand how these kind of mechanisms work, so I can later design them in Fusion. But the idea is that we can have some kind of a millimeter to steps mapping, and with that mapping we can control a piece of scientific equipment up and down very precisely using very cheap parts. So if you have some ideas on you would like me to build or something interesting that you would like to share, please feel free. And if you're an artist or designer or fellow engineer and you would like to build something, please feel free to reach out, and then let's build some cool things. And with that, I think I will just turn the stream off. Thanks a lot for watching. I think that's me.